This video covers sections 5.3 and 5.4. And in 5.3 we're going to first introduce some key definitions involving what polynomials are, how we classify them, and then after that we're going to talk about how to add and subtract them. So starting off with a definition, the idea of what is a monomial. Monomial is a one-term expression, and it can be either a constant, which is a number, or it can be the product of a variable, or more than one variable, and a constant raised to a power. So some examples: one monomial might be just the number 3. Another example might be 2 times x. It's the product of a constant and a variable. We could have something like 3y to the third. So there's a constant with a variable raised to a power. And you could have even terms like this, like x squared, y to the 5th power, z to the 3rd. So that's 3 variables raised to 3 different powers, all multiplied together. These are all monomials. They're all one term. Now, a polynomial, that's the next definition. A polynomial is the sum of many monomials. So there could be 2 monomials, 3 monomials, but the idea is that a polynomial is a bunch of monomials added or subtracted together. So maybe an example here might be x plus 2. That's a polynomial with 2 terms. We could also have something like x squared plus 5x minus 1. That has 3 terms in it. And you can have x to the 3rd minus 2xy plus y squared minus 5. There's a polynomial with 1, 2, 3, 4 terms. There's many different types of examples, and there's basically 2 ways to classify polynomials. The first way is by the number of terms. So if you take one like we have above, it has 2 terms. We have something like that, like x plus 5y, something with 2 terms. That's called a binomial. If you take a polynomial with 3 terms, maybe x squared plus 2x plus 1, that has 1, 2, 3 terms, that's a trinomial. And of course we already saw that a polynomial with 1 term, like 5x, that's a monomial. The second way is by the degree of the polynomial, which is basically the highest power. It's the highest power to which the variable is raised. So we have a table here with some different polynomials. We can classify this first one because it has 2 terms. That makes it a binomial. And then the highest power we see x raised to is x raised to the 4th power, so the degree is 4. Okay, the next line has 1, 2, 3 terms, so that's a trinomial. And the highest power of x is 3, so the degree is 3. The next polynomial has 1 term, so that's a monomial. And the degree on that is 2. And the last one is again monomial because there's 1 term. Now this one has no x's, so x we could think of as raised to the 0 power, which makes it degree 0. One more definition here. We have definition of coefficient. The coefficient of a term is the number that's in front of the variable part in the term. So let's make a little table here. So in the top row here we'll have the term, and the bottom row will have the coefficient. So the first term is 8x cubed. The number in front of the x cubed is the 8, so the coefficient is 8. The next term is negative 8x squared, which means the coefficient is negative 8. The next term is negative x. Now this one's not quite as obvious, but there's actually a 1 hanging out there in front of the x. It's like negative 1 times x, which means the coefficient is negative 1. And then the last term is 20, which is the same as the coefficient. The coefficient's 20. We can also talk about how to evaluate polynomials. So it says evaluate x squared minus 9xy minus 4y squared for when x equals negative 2 and y equals 5. You might guess that that means we take wherever there's an x, so like right here, it's x squared, but x is negative 2, and then we bring minus 9 times x, again x is negative 2, and then times y, but y is 5. Remember when we plug in, we put the numbers in parentheses, and then we have minus 4 times y squared, but y is 5. Okay, negative 2 squared is 4. We have minus 2 times positive 2 is 18. And 18 times 5 is 90. So we have plus 90 here. And we have minus 4 times 5 squared. 5 squared is 25, and 4 times 25 is 100. So 4 plus 90 is 94, but then we subtract 100 away from that, and we get negative 6. Now the last thing we're going to talk about in this section is how to add and subtract polynomials. And so the main thing you need to remember is, really, actually, this is something you've done before. When you add or subtract polynomials, all we're doing is combining like terms. So that means in this first one, the 2x squared and the 5x squared are like terms. It means that the positive 3x and the negative 6x are like terms. It means that the positive 4 and the negative 3 are like terms. And so one thing you could do is we could just rewrite this. We could rewrite it as 2x squared plus 5x squared. Those are like terms. And then we could have the x's, so plus 3x minus 6x. And then plus 4 minus 3. And then when we combine those like terms, 2 and 5 is 7x squared. 3x minus 6x is negative 3x, and 4 minus 3 is positive 1. Now another way that people will sometimes do this when you add polynomials is they will line up the polynomials. So you could write it like 2x squared plus 3x plus 4 added to 5x squared minus 6x minus 3. If you want to do that, that's fine. You see the answer is still the same. I think it just takes more work to rewrite it like this. Notice it's the same answer. Okay. We also have an example B here. Now what are the like terms in this one? We have x squared plus 7x plus 4x plus 28. There's only two like terms, and that's the 7x and the 4x. 7x plus 4x is 11x. So the x squared stays. 7 plus 4x is 11x plus 28. And there you have it. Now subtraction is a little bit different, because when we subtract, that's like almost like there's like a negative 1 here. And so it's like you're distributing a negative 1. So I like to even write out, let's think about this as distributing the negative. Distribute the negative. And when you do that, what effect does distributing the negative have on the polynomial? Well, it changes all the signs. So let's go ahead and rewrite the first polynomial. Actually, that's a trinomial because it has 3 terms. If we rewrite it, and we can drop the parentheses on that one, so that's just going to be 5a squared minus a minus 6. And then if I distribute, I take negative 1 times negative 3, that makes positive 3a squared. And then again, you need to change the sign. Negative 1 times negative 2a changes that negative 2a to a positive 2a. And then again, negative 4 times negative 1 times positive 4 makes negative 4. Now again, we combine like terms. We have 5a squared and positive 3a squared. That makes 8a squared. Then we have negative a plus 2a is plus 1a. Then we have negative 6 minus 4 is negative 10. There you have it. One last example here. So to combine like terms, we have y squared. There's only one y squared term, but then we have 2 y terms. Negative 18 plus 2 is negative 16y. And we have the minus 12 left over. And that is section 5.3. We're also going to cover section 5.4, which is about how we multiply monomials and polynomials. So the first type is, what do we get when we multiply 2 monomials? For example, we have negative 2x cubed times 5x squared. Well, easiest way to think about this is to multiply the numbers separately. So we have negative 2 times positive 5, and then to multiply the variable part separately. So we have x cubed and then an x squared. Of course, negative 2 times 5, that's negative 10. And then remember, when we multiply exponents, we add the powers. So 3 plus 2 is 5. So this is going to be x to the 5th power. Now, this middle step here, this negative 2 times 5 times x cubed times x squared, where I rewrote it, you do not have to write that out every time. But mentally, in your head, that's what you want to be doing. You want to say, okay, I want to multiply the numbers first. Negative 2 times 5, that's negative 10. Okay, write that negative 10 down. Then we have x cubed times x squared. That's going to be x to the 5th. You don't have to write out that middle step. Okay, now in the next example, can you think what might happen here? I have 2x squared times parentheses 6x squared minus 3x plus 5. What do you think we might do here? Hopefully what you're thinking in your head is that we want to distribute, because if that's what you're thinking, you would be right. And now we're going to use that idea that we used in the previous example where we multiplied monomials, because we're going to multiply the numbers and the variables separately. So if I take 2x squared times 6x squared, that's the first one. Take the numbers, 2 times 6, that's 12. And then x squared times x squared, add those powers, 2 plus 2 is 4. Okay, then I move on to the next one. I'm going to distribute the 2x squared now times the second term, the negative 3x. So we multiply the numbers first. 2 times negative 3, that's negative 6. And then x squared times x, and we can think of this as the power of 1. So we have 2 plus 1, that's x to the 3rd. There's 3 x's there. And then we have the last product. The last product is 2x squared times 5, so we take the 2 times the 5, both positive, so that's a positive 10, and then it's only the x squared. There's no x next to the 5, so this is going to be 10x squared. And there you have it. What happens when we multiply two polynomials? Well, here we have 3x plus 5 times 2x minus 1. We are going to do really a double distribute here. We're going to take 3x and we're going to distribute that times the 2x and also times the negative 1. And then after we have distributed the 3x, we're also going to distribute the 5. So we're going to take 5 times 2x and 5 times negative 1. Okay, so when I multiply that out, starting with the red first, I have 3x times 2x. 3x times 2x. So we take 3 times 2 is 6. And x times x is x squared. Then we move on to the second red. 3x times negative 1. So now we have a positive times a negative. 3 times negative 1, that's going to be a negative 3. And then that x stays with it. Okay, now we move on to the blue distribute. We have 5 times 2x. 5 times 2 is 10, and that's a positive 10. And there's an x there. And then the last product is 5 times negative 1. 5 times negative 1, positive times a negative, that's a negative 5. Then you want to ask yourself if we're done. Well, there are some like terms there. We have two middle ones are like terms. And so we have 6x squared, and then negative 3x plus 10x, that's a plus 7x. And then the minus 5 stays on the end. Now, this process of multiplying two binomials often is given a special name by teachers and books. Notice there were 4 products. And a lot of times what teachers will call this is they'll call it FOIL. You may have heard this in another class. It's kind of a memory tool to help remember what we're multiplying. Because the 6x squared, that came from multiplying 3x times 2x, and those were the first terms in each of the binomials. So that f, it stands for first, because those were first terms. Okay, and then the negative 3x, that came from taking 3x times negative 1. Well, those are the terms that are on the outside, the 3x and the negative 1. So the O stands for outside. And then we come to 10x. 10x came from taking 5 times 2x. 5 times 2x. Those are the two inside terms. So that I stands for inside. And then lastly, the L, that came from the 5 times the negative 1. Those are the last terms of each binomial. So L stands for last. But really, I think the easiest way to think about this is you just have to distribute twice. Distribute twice. So let's try that again here on the next one. I'm going to distribute 2x times 3x and negative 5. And then I'm going to take 3 times 3x and negative 5. So when I do that, first I have 2x times 3x. 2 times 3 is 6. X times x is x squared. And then 2x times negative 5, that's negative 10x. Then we move on to the second part. We have 3 times 3x, that's plus 9x. And then I have 3 times negative 5. That's a positive times a negative, so we have a negative 15. Combining like terms, I have 6x squared, negative 10x plus 9x, that's negative 1x or negative x, and then minus 15. Now the next one, we're going to again distribute twice, but now we have 3x times not 2 terms, but times 3 terms. And likewise, we have to take that negative 2 times 1, 2, 3 terms. So we're going to have 6 products we have to take here. So starting out with the red, 3x times 2x squared, that's 6x cubed. And then we have 3x times negative 3x is negative 9x squared. And then 3x times 4, that's plus 12x. And then we move on to the blue. We have negative 2 times positive 2x squared. That's negative 4x squared. And then we have negative 2 times negative 3x is positive 6x. And lastly, negative 2 times positive 4 is negative 8. Go and combine some like terms here. Negative 2x squared, negative 4x squared, and positive 12x and positive 6x. We have 6x cubed. Combine the yellow like terms. Negative 9 added to negative 4 is negative 13. X squared. Add the blue terms. 12x and 6x is positive 18x. And then the minus 8 on the end. Now there's also some special products. There's what we call the difference of squares and the perfect squares. The first one, when I have a difference of squares, it's going to turn out the two middle terms always cancel out. So I distribute again. I take a times a is a squared, and a times negative b is negative ab. And then we distribute the b times a, that's a positive ab, or b times a. And then a b times a negative b, that's a negative b squared. And so you can see here the negative ab is going to cancel out with the positive ab. Two middle terms cancel, and we get a squared minus b squared. These ones cancel. And they will always do that when we have this difference of squares form, where the a and the b are the same, but the difference is there's a plus on one binomial and there's a minus on the other. Now that's a little bit different than when we have a plus b squared, because remember what the exponent means is you take the base and you multiply it by itself twice. So this means to take a plus b and multiply it by itself. Likewise, a minus b squared means to take a minus b times itself. And here we do not see the middle terms cancel. Here we see a times a is a squared, and then a times b is plus ab, and then we have b times a, well that's another ab if we rewrite the order of multiplication, and then lastly b times b is b squared, and the two middle terms here are like terms. We have basically 1ab plus 1ab, which is 2ab. So this is a squared plus 2ab plus b squared. And this one similarly will be a squared minus 2ab plus b squared. So we have some examples of these different types of special products, the difference of squares and the perfect squares. And you'll notice that this first one is one of those perfect squares. So this means to take x plus y times x plus y. And when you distribute, you have x times x is x squared. and then you're going to have an x times y here. You're going to have an x times y here, and then an x times y here. So that's 2xy, and then you'll have a y times y is y squared. I skipped the middle step there because I know that those two middle terms, just like where we highlighted here in green, those two middle terms were the same, so we're going to have two of them. You'll always have that idea when you have a perfect square. Now look at the next one. This is not a perfect square. This is a difference of squares. So I have x times x is x squared. And then I'm going to write out this next one, but we don't really have to. So we have x times negative 2. Let me write it in a different color. This is negative 2x. And then the inside is 2 times x. That's positive 2x. And what happens with those? They cancel. They will always cancel with the difference of squares. Always. In the last one we have positive 2 times negative 2, that's negative 4. So your answer here is x squared minus 4. So I encourage you to get used to writing it that way, and don't even write out those middle terms because you know they're going to cancel when you have a difference of squares. So we also have this 3x minus 2 squared, which remember that means 3x minus 2 times 3x minus 2. 3x, distributing, 3x times 3x is 9x squared. And then remember the next two terms are the same. So we have 2 times, or 3x times negative 2, and then negative 2 times 3x. 3x times negative 2, that's negative 6x. And two of those, multiply that by 2, that's negative 12x. So we'll have negative 12x, and then negative 2 times negative 2, that's positive 4. Now, if you don't want to use the shortcut like I just did, where you follow this rule up here, follow that rule where you have your middle term, your a times b, there's two of them. If you don't want to do that, you can always just distribute it out and combine like terms. There's nothing wrong with doing that if you don't like the shortcut. What I mean by that is there's nothing wrong with taking 3x times 3x is 9x squared, and 3x times negative 2 is negative 6x, and then negative 2 times 3x, that's another negative 6x, and negative 2 times negative 2, that's positive 4, and then negative 6x plus negative 6x is negative 12x. You get that same answer. There's nothing wrong with doing it the long way. Okay, the last one, this is another one of those difference of squares, because notice we have 8x and 8x, and 2y and 2y, but the difference is this is a plus 2y and this is a minus 2y. This means the two middle terms will cancel. So all we really have is we have 8x times 8x. 8 times 8 is 64. X times x is x squared. The two middle terms cancel and we're left with just 2y times negative 2y. That makes negative 4y squared. Again here, if you don't feel comfortable using the shortcut, you can always write it out. 8x times 8x is 64x squared. 8x times negative 2y, that's negative 16y. 2y times negative 16xy, excuse me. Let me rewrite that. Negative 16xy, and then we distribute the 2y. 2y times 8x, positive 16xy, and 2y and negative 2y is negative 4y squared. And you cancel out the middle terms, and you get what we got with the shortcut. That completes section 5.4. I will see you in class. Thank you.